Well, let's do some, we've been learning about oxidation numbers. Once again, we know that oxidation numbers is the apparent charge of a molecule or an element, okay? And we know now that that's not just combined with oxygen, that can be combined with any other element on the periodic table. So once again, we've got our rules over here. We've talked about those already, okay? We also know that if we say an ion, okay, if we say an ion, then we go directly to the periodic table. So now let's do some practice ones. I just put some up here at random, trying to give us an example of all the different rules. So you can practice a lot of these. This kind of stuff you're going to have on your test. And once again, it won't be these exact ones, but you can practice them. It's a skills test. Once you understand the rules, no matter what I give you, then you don't have to memorize. Like I don't want to memorize the oxidation numbers for NH3, which is ammonia. I don't want to memorize that. I want to just know by the rules. Okay. So well, let's go through and let's do some examples here. Okay. Let's do some examples. So the first thing I'm going to ask myself, okay, when I see NH3, okay, which rules are going to be rule 1, 2, 3, or 4? Well, the first rule I'm going to have is it's not in the zero state because it's combined with something. But rule number 2, it is a hydrogen, okay? And there's a hydrogen because remember, if I know one of the elements, then I can do the other element because I just got to have them equal 0, okay? Once again, stable, they want to be stable, okay? So once again, so here we go. So hydrogen, so what's my rule for hydrogen? It's +1 unless combined with groups 1 or 2. And nitrogen is not in groups 1 or 2. So I know right away that hydrogen is +1, okay? Once again, if I don't know my rules, I'm not gonna know what the oxidation numbers are, and you can't have notes on the rules. Why is this? Because you're going to need to know this when you get out in the field as a chemist and you're doing stuff quick. You go, okay, well the only thing I really need to know is if it's by itself, it's a 0. If it's a hydrogen, what the rule is. Well, the rule is a +1. Let's combine with groups 1 or 2, and then it's a -1. And then we say, oh, then there's oxygen. What's the rule for oxygen? Oh, it's -2 unless it's a peroxide, and then it's +2. And then I go, oh, if it's not one of those, it's the most electronegative. So you kind of, even though it may look hard, as a chemist, I can tell you, once again, we're trying to think like a chemist. It's a big thing. Got to know what the oxidation numbers are. So I see to myself that that's a +1. So what's the charge going to be on this nitrogen? Well, I can't just put a -1 because I've got a subscript here telling me I have 3 hydrogens, and each one of them is a +1, so that's a +3. So in order to make this stable, the nitrogen is a -3. Okay, so I wanted to give you one of those examples to where the subscript is not the same for both ones. Okay, so I got to say, how many plus charges do I have? Well, I've got 3 of them. Okay, why? Because the subscript's 3. I have 3 hydrogens here, so I have to say to myself, okay, what makes a 0 charge? That's a +3. Why? Because of the subscript. So that makes that a -3. Well, so then I go to the next one, and as a chemist, and being a chemist, the thing that stands out to me the most, I don't even have to go through my rules, I look real quick and I go, oh, does it have a hydrogen? Oh no, but it's got an oxygen. Hydrogen and oxygen are quick. That's my oxidation numbers. Does it have a hydrogen? Does it have an oxygen? If so, it means something to me. Okay? Well, right away I see this has an oxygen, and it's not a peroxide because it's not something 2O2. It's just, okay, once again, we look up and P is phosphorus, so this is phosphorus dioxide, okay? So that actually is really kind of interesting because this is a chemical that occurs, this chemical occurs in your washing machine. Whenever you put your laundry soap in, okay? Whenever you put your laundry soap in, and we have the phosphates in your laundry soap, and it mixes with the oxygen, we actually make PO2. Well, what's interesting is if we don't get a 0 charge, then we have a problem. So right away, oxygen is a -2 here. Okay, interesting. All right. So oxygen is a -2. So what do we have here? So what's the total charge on this oxygen? Well, it's a subscript 2. So -2 times 2 is a -4. So the phosphate then is a +4. Okay. All right. There we go. All right. So once again, and we got. I know it seems tricky. I don't want you to get caught up in the math of it and go, you know, -2 times a -2. Don't worry. No, we have 2 -2 charges, so we have a total of -4 charges. So the phosphate's a +4. Now I look at this when I say, okay, I want to do the oxidation numbers, and I say, oh, there's not a hydrogen, there's not a oxygen. So now here we go. First time we got to come in here. Rule number 4. Okay, rule number 4 we use a lot. Rule number 4 says if it's not in the top 3, then it's the most electronegative. Okay, now remember when we did, I told you we would be using this periodic trend. I told you we would be using this earlier in an earlier test. Electronegativity on the periodic trend is up and over. So which one is the most up and which one is the most over of nitrogen and fluorine? Okay, well, that's pretty cool. Here's nitrogen right here, element number 7. All right, and here's fluorine number 9. So the most up, well, they're both up, okay, which is the most over? Fluorine. So fluorine is the most electronegative. So what's the rule? Most electronegative is a -1. I can always remember that. Electronegative, negative. So that's a -1. So once again, since fluorine is the most electronegative, meaning it's most to the right there, okay, then fluorine is a -1, okay? And it's exactly how we write them. We take the formula, we put the number on there. So fluorine is a -1, and there's 3 of those, so that's -3. So nitrogen is a +3. Okay, nitrogen is a +3. Now, then we have calcium dioxide. We look at that. Right away, we say, okay, cool. There's an oxygen in there. What's the rule for oxygen? It's really cool. Is calcium in groups 1 or 2? And the answer is yes. Yes, there sits calcium. There sits calcium right there on. There sits calcium right there, element number 20 in group 2. And I wanted to show you this because this happens in our bones. This happens in our bones. A very, very interesting reaction in our bones. So here we go. So what's the rule for oxygen? Okay. All right. I'm sorry. I started to get ahead of myself. Okay. Oxygen is -2 except a peroxide. I got ahead of myself. Okay. Oxygen is -2 except in a peroxide. So I look at this, that's pretty quick. So what is oxygen? That's not a peroxide. It's not, if it was a peroxide, it would be Ca2O2. So once again, I see oxygen, and here's my rule. Okay. Oxygen is -2 except in peroxides. So once again, I have a -4, so that makes the calcium a +4. Now, what's interesting about that, and I mean, we're going to talk about biochemistry later. We teach human anatomy. It's really fascinating. But what does this mean? This is Ca +4. It means that is that extra electrons or is that minus electrons? No, that's minus electrons. That means that calcium is missing 4 electrons in group 2. Well, that's interesting because that means it goes into the next energy level. Wow, it drops down an energy level. And so I would ask you, does calcium break down fast or break down slow? And the answer is calcium breaks down fast until it does what? Combines with oxygen, and then it becomes stable, and then the oxygen comes in here at a -2. We get 2. Oxygen is diatomic in the air, okay, and the charge is -2. So calcium absorbs quickly in your body. That's big. If calcium absorbs slowly, we would have a real problem until it does what? Mixes with the oxygen. Then what happens? It becomes stable, and then calcium doesn't absorb anymore at all. Wow. So it's big for our bones that calcium absorbs quickly. All right. So once again, back to our oxidation numbers. What's the oxidation number for CaO2? Oxygen is -2 because that's not a peroxide, so that makes calcium +4. Hopefully we're doing enough that you're getting the hang of it. By the time we get done here, you'll be like, I got it, no more. I've had plenty. Don't give me another example. But let's just do several here. Okay, so now we have barium oxide, okay? So I go in here once again. Now here's oxygen, same rule. Okay, so same rule. It's -2. All right. So what does that make? What does that make a barium? It makes it a +2. Oh, so you know we're getting the hang of it. Now we have the same thing here. Na2O. Okay. So what's the rule for oxygen? See, that's not a peroxide, or it has to be Na2O2. So once again, that makes that a -2. But now what do we have here? There's 2 of these, so that makes that. So now we got to look. Now we got to look. Okay, this is why I give you this example. The charge has to be 0. The charge has to be 0. So what's a charge on the negative side? -2. So that makes this charge +1. Why? Because we have 2 of them. So now the net charge for the sodium, the net charge here is a +1, but there's 2 of them, so that's a +2. What's the net charge over here? It's a -2. So the whole thing is equal to 0. See how so we got to say, okay, so I wanted to give you something like that. It looks a little different. Same animal, just a little different species. Okay. So once again, I'm calculating the oxidation number. for Na2O. So the rule once again is -2, but I want to make that it's a -2, so I'll make this a +2, but there's 2 of these, so that's +1. Okay, let's go to the next one, Na2O2. Now we have a peroxide. Now we have a peroxide, Na2O2. So what's the rule for a peroxide? Now in a peroxide, okay, all right, now in a peroxide, it's +2. Oh, that's kind of interesting, okay. All right, oxygen is -2, except in peroxides where it's a +2, so that's going to make this a -2. Isn't that interesting? Isn't that interesting? Okay, so let's look at oxygen once again. Oxygen is -2, okay. Oxygen is -2, except in peroxides where it's a +2. Okay, oxygen is a -2, except in peroxides where it's a +2. So that makes this a -2. So that makes that +2. Now it's interesting though, because then the sodium kind of switched around a little bit on us. Okay. All right. Now let's do KH. So once again, we look at it. We say, okay, does it have a hydrogen? Oh yeah, it has a hydrogen. So what's hydrogen? +1 unless it's in groups 1 or 2. Is K in group 1? And the answer is yes. Oh, so that makes this a -1. So that makes that a +1. Now let's do water. Okay. Now let's do water. Water is totally cool. Water is the magic of chemistry. Okay. So we say, oh, it's got a hydrogen and an oxygen. Oh, here's the true test. What's our first rule? Well, it's not in the uncombined state. So hydrogen is the first rule. So we're going to go in the order of the rules all the time. Hydrogen is +1 unless in groups 1 or 2. Oxygen is in group 16. So this is going to be a +1. Well, so there's 2 of those. So that's going to make this a -2. It's kind of interesting that the rules still work. What's the rule for oxygen? -2 unless it's peroxide. So it fits the rule both ways. So hydrogen in water, the hydrogen's +1, the oxygen's a -2. Okay, let's do one more, okay. Copper dibromide, okay. So, does it have a hydrogen? Does it have an oxygen? So we got to go to electronegativity. So let's look at our periodic table. We say, okay, copper, okay, what do we got? I see you, copper. Okay, here's copper right here, okay. Now, where's bromine? All right, where's bromine? Oh, it's over here. Now, it kind of worked nice. We didn't have to worry about the up, but we got to figure the over. And once again, electronegativity. Up is more electronegative. Over is more electronegative. So when we look at copper and we look at bromine, we see that bromine's more electronegative. So what's the more electronegative? It's -1. So that makes this a -2. See, when I look at these combined, I have a -2. So what does that make copper? +2. All right, so now, okay, so that's just a good scattering. Hey, now that looks, see, once again, it looks pretty confusing, but when you know it, it's relatively easy. When you understand what it is and why it is, it's relatively easy. Chemistry is not hard, it's just a matter of knowing what it is you're doing. So now let's do the ions. So look, when I see that ion, okay, right away, when I see the ion, when you see that ion on your test, you've got to go directly to your periodic table. Now, all of these are automatic. They're automatic. Sulfur, sulfide ion. Where's sulfur? Right here. It's in group 16. Okay. Now, remember, group 18 is 0, -1, -2. So a sulfide ion is -2. Got to go right to the periodic table. Remember, it goes 0, -1, -2, -3, -4, -5. And then groups 1 and 2 are +1 and +2. Okay, so now let's go to calcium. Okay, here's calcium. Calcium's right over here. It's in group 2. That's a +2. What's the oxidation number for calcium? +2. Why? Because everything in group 1 is +1. Everything in group 2 is +2. Now let's go to chlorine. Okay. Wow, it's group 17. You know, group 18 is 0. Group 17 is -1. I could have said that was chloride ion. I could have said bromine ion. I could have said iodine ion. Anything in group 17 is -1. Now, barium. Okay, barium is over here in group 2. Okay, anything in group 2 is +2. Now, what if I had said a potassium ion? Well, it would be +1 because it's in group 1. Any ion here would be a +1 in group 1. Any ion here would be a +2. And any ion here, which you can't have an ion for noble gases, but anything in 17 is -1, 16 is -2, 15 -3, 14 is -4, and 13 is -5. So, we're going to wrap that up with examples, and we're going to be back with the next video.